Right, we're looking at congruent shapes. And this is where we get the other word, congruency. Not sure how you pronounce that. Congruency. Right, so shapes can be congruent. You were saying something about congruency. What do you think are congruent shapes? Yes.
When a shape is exactly identical. When the shape is exactly identical.
They're identical in what respect?
Shape.
Identical in
I think it's shape and size.
Identical in shape and in size. That's good. That's correct. Identical in shape and in size. What do we use to measure size?
Kilogram. Grams.
Size.
Size. Sorry.
In terms of units.
Just put your hand up if you know the answer. Yes, Matthew. We use the sides of the shape. Okay, we can make use of the sides of the shape to determine whether the size of the shapes are the same. So in other words, we can measure the length of the sides. Okay, yes. What else, Bryce?
Wouldn't you use area?
We could use area as well. What do you think? Can you elaborate on that?
Well, the thing is that size will work, but it's essentially just doing area if you measure both sides. But the thing is with areas, it gives you a better idea of the actual size.
Okay. Yeah, but yeah, we need to remember something about identity. Do you know that two different shapes can have the same area? Like a circle can have the same area as a square. But that circle definitely is not congruent to the square. So you are right. Obviously, for any two congruent shapes, we expect their areas to be the same, which comes from the fact that probably their sides and their shape are the same. So the areas will be the same as well. Okay. Anything else? Yes.
So could you use the angles?
Could we use angles? Do you want to respond to that? Okay, can we use angles? Yes, we can use angles. Angles will actually determine also the size, but we know something about angles as well. We can't just use angles on their own. Do you know that two shapes can have same angles, but the shapes can be different? Like, you could have this thing as 60 degrees, 60 degrees, 60 degrees, and this one is also 60 degrees, 60 degrees, 60 degrees.
So no.
That is possible, right?
Yes.
All right. So we need to be careful. Yes, we will use angles to determine the size, but we need to be careful. Angles on their own will not be enough, because we can get a triangle like this one and a bigger triangle like this one. Clearly, these are not congruent. That is why we have to go back to size and shape. The shape looks like the same, but the size or the sizes are different. But let's assume that there is a triangle. I think we can draw a triangle with a side of 13 centimeters and 15 centimeters and 20 centimeters. So if I give you this information, suppose you have the equipment, and I give you this information, guys, draw a triangle that has one side equal to 13 centimeters, another side equal to 15 centimeters, and another one equal to 20 centimeters. Do you think you guys will draw different things if you all draw them accurately? Do you think you'll draw different shapes? Well, the kind of shapes you will draw will be congruent, right? If I ask you to cut them out using a pair of scissors, you cut them out and give me your triangles. I'm sure we can actually put them together, superimpose them together, and they would appear like one shape. We agree. So those are examples of congruent shapes. So these two shapes are congruent. I want you to name the congruent shapes. Right, somebody please name the congruent shapes. This is one thing that we shall be asking you to do in the test. So given shapes that are congruent, can you name them? In this case, these are triangles. Can you name the congruent triangles? One person. Yes, Matthew.
Triangle ABC is congruent.
Let me write that one first. Triangle ABC
Congruent to triangle P2R.
is congruent triangle, you said P?
PQR.
PQR. Do you agree? She doesn't agree. We'll find out why. But you said ABC is congruent to PQR. Okay, this is somebody's opinion. Let me call it A. What do you think?
So I think it's ABC, and ABC is congruent to triangle QPR.
QPR. Okay, so you think QPR. So ABC is congruent to QPR. QPR. You are naming the same triangles, right? Do you see that?
Yes.
But do you see that the order in which you are naming these triangles is different? And when you are naming congruent shapes, you will need to pay attention to the order. You don't just name them, so you name them in the right order. And this is the right order. You name them in such a way that the angle, let's take this one for instance. The angle at A must be the same size as the angle at P. So these are starting. A starts here and P starts there. So is angle A equal to angle P? Number two, is angle B equal to angle Q? And is angle C equal to angle R? I know that angles are not given. Now, because the angles are not given, let me show you something else. You are saying triangle ABC is congruent to PQR. This is the symbol we use for congruency. So I'm just going to draw those three lines for congruent. So you said PQR. If that is correct, then the length AB, how do I show you that? This length AB should be the same as the length PQ. Can you check? Is AB equal to PQ? So I'm saying, ask yourself, is AB equal to PQ? You said yes. Also, the length BC and the length QR should be equal. Is BC equal to QR? Look at the diagram. BC, they are not, right? Okay. And then the length AC and the length PR. So is AC equal to PR? No again. Okay, so you know that you did not name them properly. Okay? Let's check the second one. She said ABC is congruent to QPR. Right. Do you think AB is equal to QP?
Yes.
You said yes.
Yes.
All right. What about, so it's AB and QP. What about BC and PR?
Yes.
Again, yes.
Yes.
And finally, so that was BC and PR, then AC and that one. What about AC and QR?
Yes.
Yes. So they are equal. Therefore, the two triangles are congruent. Okay, guys? So the two triangles are congruent. So do you think you know how to name congruent shapes now?
Yes.
Well done. Well done.